Welcome all for the today's session. We continue with our biostatistics module, and today's topic for the discussion is measures of variability. Last session we have seen the measures of central tendency, how the data is centered around one particular value. Now we are going to see how each observation is varying from each other or varying from the mean. Okay, so what is the measure of variability? Okay, so it shows the spread or the scatter of the data. Two data sets may have same mean but different variability. Okay, so when you have got a two data set, the both data set may have got a same mean, but each observation may be behaving differently around the mean. Okay, so how is the behavior with respect to the mean in two observations? That all we are going to discuss in the measures of variability. Now, what are the measures of variability? First is a range. Okay, what is the formula for the range? Range is equal to maximum value minus minimum value. So when you have got a data set, you arrange the data set in order from lower value to the higher value. Then you calculate the maximum value, you subtract the minimum value from that. That is the range. Okay, it is the simplest variability measure, but it is affected by the outliers. Okay, so range calculation, that means your data is varying from, suppose you are given a 20 observation, and these 20 observations are extending from, say, number 2 is the least observation and 48 is the highest observation, and there are in between there are 20 observations total. Okay, so your range will become 48 minus 2. Okay, 46 is the range. Okay, so maximum value minus minimum value, that is what is the range. Very simple. Now next concept is the measure is the interquartile range. Okay, so this interquartile range is the spread of middle 50% of the data. So interquartile range talks about the middle 50% of the data. How do we calculate the interquartile range? Interquartile range is equal to Q3 minus Q1. So where Q3 is the third quartile, that is the 75th percentile, and Q1 is the first quartile, that is the 25th percentile. Okay, so if we divide the whole data set into quartiles, okay, if you have got a 4 quartiles, then the third quartile minus first quartile will be the IQR, and in this interquartile range you will have got the middle 50% of the data. Okay, and the advantage here is that this middle 50% data, there will be no outliers. Outliers will be in the first quartile and the last quartile. Okay, so here this will be independent of the outliers. So important feature is resistant to the outliers. This concept is very clear. Interquartile range resistant to the outliers, and formula Q3 minus Q1. Okay, and on this concept you have got a box Whisker plot. Okay, now what does this box Whisker plot show? It shows the median, it shows the quartiles, it gives us the interquartile range, it talks about the outliers. Okay, and important thing is that outliers are beyond the whiskers. Okay, so the outliers will lie beyond the whiskers. Okay, so look at this particular box Whisker plot. Okay, so the data set is divided into the quarters. This is the first quartile, this is the second, and this is the third quartile. Okay, and these are the whiskers. Okay, these are the whiskers. Okay, now this is the median or the second quartile, and interquartile range will extend from the Q3 minus Q1, and here in this particular box will be the 50% of the observations will lie here. Okay, so interquartile range deals with the 50% of the observation, and don't think that this will be always be equal. Okay, so it may be here also, one may be small, one may be large also. Okay, so interquartile range. Okay, here is the division into 4 quartiles, and each quartile will have 25% of the observations. Okay, and middle 50% of the observations around the mean, they are come in the interquartile range, and the outliers will be beyond the whisker. This is the whisker. Okay, remember, though here it is written as a minimum and maximum, this does not, the whisker does not include the outliers. Okay, suppose your data set has got a 50 observations, and there are 2 or 3 outliers, maybe one outlier on this side, maybe two outliers on this side, but this minimum and maximum value will exclude the outlier, because there is an extent to which this whisker will extend. There is a formula. Okay, this is the interquartile range you are calculating. So lower uh, uh, whisker and the upper whisker range is fixed by a particular formula, and any observation which is beyond that will be the outlier. Okay, so it is quartile 1 minus 1.5 times of the interquartile range. That will be the extent of this whisker, while from the third quartile, your whisker will extend quartile 3 plus 1.5 times of the interquartile range. So you have to extend that 1.5 times on this side of the interquartile range and 1.5 times the interquartile range on this side. And whatever observation will lie beyond that will be the outlier. Okay. So here it is explained same thing. Here, this is the median. This is the quartile 1. This is the quartile 3. Remember, all quartiles are not same. What we are discussing, where the 25% of the observations are lying in the quartile 1. Then another 25% are lying in this much of range only. Okay. Suppose there are 100 observations. Okay. But 25 observations are between this value and this value. But next 25 are between median is suppose say 40. So you will have 25 observations between, suppose here it is 20 and here it is 40. Between 20 and 40 there will be 25 observations. Okay. So next 25 observations will be in this particular range, and last 25 observations will be in this particular range. Okay. So this is Q3 minus Q1 is the interquartile range. Okay. So this is here. See, here they have given the extent of whisker. Q1 minus 1.5 times of the IQR. This is the interquartile Q3 minus Q1. Okay. Suppose here it is a 20 and here it is a 40. Then 40 minus 20 is the interquartile range. 1.5 times of the IQR. Okay. If it is a 20, then you have to do the 1.5 times. So that will be 30. So you will go 30 on this side. That will be the minimum range of the whisker. Then same, you will go Q3 plus 1.5 times of the IQR. Suppose here it is 50 value, then 50 plus interquartile range, whatever is there, you do the 1.5 times and go on this side. That will be the limit of your whisker. And any value which lies beyond that will be the outlier. I hope you are getting this concept. Okay, that much detail will not be asked, but most important thing to remember, how will you calculate the interquartile range? And the advantage is that the outliers will lie beyond the whiskers. Okay, so now next concept of variability is a standard deviation. Okay, standard deviation. So what is standard deviation? It is the average spread around the mean. Okay, you have got many observations and there is a one arithmetic mean you have calculated, but how much each observation is varying from the mean. Okay, each observation may be varying from the mean. Okay, then what is the variability of individual observation? That is decided by the standard deviation. Okay, now you may have the standard deviation which is small, you may have got a standard deviation which is large. Now if you have got a small standard deviation, that means values are close to the mean. Okay, suppose you have got a mean as a 50. Okay, you have got a 100 values and you have got a mean as a 50 and you have got a standard deviation which is very small. Okay, then you might have got all 100 values around the 50 lying between say 45 to 55. All 100 values are between very close to the mean. You will get a small standard deviation because individual value is not very far from the mean. But if you have got a mean of same 50, but some value is at 40, some value 30, 20, 2, 4, that means though the mean has come 50, but individual observations are away from the mean. In that particular case, you will get the large standard deviation. That means there is a more dispersion. Okay, that means in this particular sample, the observations are away from each other, though the mean has come as a 50. Okay, so what is the formula for standard deviation? Standard deviation is the square root of sigma x minus x bar square divided by n minus 1. Okay, this is what is the formula. What you have to do, you have to first you will calculate the mean, then you will calculate the difference of each observation from the mean, and you will do the square of that. Okay, and then you will do the sum of all that, and that you will divide it by the number of observation minus 1. Suppose if there are 10 observations, so 10 minus 1, you will divide this by the 9. Okay, and you will take the square root of that. Okay, so it is the sigma x minus x bar square, okay, divided by n minus 1, and you take the square root of that. That is the standard deviation. That means how much each value is varying from around the mean. Okay, and this is called as the degree of freedom. Okay, degree of freedom is the n minus 1. Okay, so one value becomes fixed once the mean is known. Okay, so once you get the mean, you are dividing the mean, so you subtract one value. If you have got a 10 data set of 10 observation, you can calculate the mean, and the mean is one value. So how much? 9. So this degree of freedom will become 9. That is n minus 1 is the degree of freedom. So one value becomes fixed once the mean is known. Okay. Now, what is the step to calculate the standard deviation? First, you will calculate the mean, then find deviation from the mean. That means each observation you will subtract from the mean, then the square the deviation. So whatever the value you will get, you will take the square of that. Then you will do the addition of all this. Then you will divide that sum by n minus 1, and finally you will take the square root of that. Okay. So what is the interpretation of SD? If you have got a small standard deviation, that means data is clustered around the mean. If you have got a large standard deviation, data is widely scattered around the mean. Okay, so at least this concept you remember. Small SD means homogeneous sample, data is clustered around the mean. Large SD, there is a wide variation in the data set. Okay, so this concept you should remember. The next concept is a coefficient of variation. Okay, coefficient of variation. Now, how this coefficient of variation is calculated? Coefficient of variation is equal to SD upon mean multiplied by the 100. Okay, we have just seen how to calculate the standard deviation. Standard deviation is the deviation of each observation from the mean. Okay, so you know the standard deviation, you know the mean. So coefficient of variation is the standard deviation divided by mean multiplied by the 100. What are the uses of coefficient of variation? It compares the variability between variables with different unit. Sometimes you may have got the data set with different units. Okay, now if you have got a higher coefficient of variability, that means there is a greater variability. Sometimes you get a lower coefficient of variation, that means the data is more consistent. Okay, so similar to the standard deviation, small SD and large SD. Okay, so here higher coefficient of variation, greater variability is there. Lower coefficient of variation, that means there is a more consistency. What is the main use of coefficient of variation? To compare the variability between the data sets having different units and different means. So when you are comparing two data sets, okay, now the both data set have got a different mean. Okay, now you have got a data set where the mean blood pressure is 100. You have got another data set where the mean blood pressure is 120. Now you want to compare, but the mean of both data set is different. In that particular case, this coefficient of variation will help us to compare the two data sets. For example, compare the blood pressure variability versus birth weight variability. Now here we have got a different units. Here we have got a blood pressure versus birth weight. Okay, in kilogram it will be there. It may be in the gram. Here it will be in the millimeters of mercury. Then compare two lab tests with different scales. Okay, the lab tests with different scales you have. Two same test with a different scale you have. How will you compare? So here the coefficient of variation helps us. Then compare consistency between two instruments. Okay. So just for the understanding, take this particular example. Suppose you have got a one data set where mean is 100 and standard deviation is 5. Then how will you calculate the coefficient of variation? Coefficient of variation is a mean divided by standard deviation multiplied by 100. So mean is 100, standard deviation is 5. Okay. So standard deviation divided by mean. Okay. Standard deviation is 5 divided by 100 multiplied by 100. So it becomes 5%. Here the coefficient of variation has come 5%. So standard deviation divided by mean multiplied by 100. Standard deviation is 5 divided by mean multiplied by 100. So remember this particular formula. They may ask you the calculation. Okay. So it is the standard deviation divided by mean multiplied by 100. Okay. SD upon mean multiplied by 100. Okay. Now second group where the mean is 50 and standard deviation is 10. Okay. So these are the two data sets. Group A where the mean is 100, standard deviation is 5 and coefficient of variation has come 5%. Now what is happening in the second data set? Mean is 50. Standard deviation is 10. Here the standard deviation was 5. Here standard deviation is 10. Okay. Now the coefficient of variation SD upon mean, that is 10 upon 50 multiplied by 100, that is 20%. That means the variability is 20%. Here the variability was 5%. Less the variability, more consistency in the sample. Okay. Larger the coefficient of variation, that means larger is the variability. Okay, this at least you remember. Okay, so how will you interpret? Although group B has got a smaller mean, here the mean was 100 in the first sample, here mean was 50. So although the group B has got a smaller mean, it has got a much greater variability because higher CV means greater variability. Thus group A is more consistent and group B is less consistent. Okay. So another example, comparing the two blood pressure measuring machines. Okay, so you have got two machines. Machine A has given the mean blood pressure of 120. The standard deviation of the data set is 6 and coefficient of variation is 5%. While machine B has also given the mean blood pressure of 120, but the standard deviation of the observation is 18 and here the coefficient of variation has become 15%. Okay, here the coefficient of variation was 5%. Now which machine is better? Machine A is better or machine B is better? Here machine A is going to be better because it is the showing the consistent observation while it is showing the variation in the observation. Okay, so machine A is more reliable because reading are less variable. So why CV coefficient of variation is better than SD for comparison? Okay, now suppose you have got a two variables with different units. We have got a height in centimeter and weight in kg. Now in this data set, mean is 170 and standard deviation is 10. In this data set, you have got a mean of 50 and standard deviation of 10. Okay, here both have got a standard deviations same, but the mean is different. Okay, so SD is same in both groups, but relative variability differs. So what will help us to know about this sample is the coefficient of variation. Okay, so standard deviation alone cannot compare the variability properly when means differ. Okay, now here though the standard deviation is same but the means are different, so standard deviation alone will not help us, so we need to take the help of the coefficient of variation. So when you have got a two different data sets, when the mean is different or when you have got a comparison of two different units, in that particular case this CV, that is the coefficient of variation, will help us. Okay, SD alone cannot compare variability properly when means are different. Okay, so coefficient of variation standardizes variability relative to the mean. So this coefficient of variation will standardize the variability relative to the mean. Okay, so just for the understanding point of view, remember CV compares consistency. Okay, so coefficient of variation compares consistency. Coefficient of variation is the variability relative to the mean. Okay. So coefficient of variation is the percentage ratio of standard deviation to the mean. So SD upon mean multiplied by 100 is nothing but the coefficient of variation. This formula you remember. It is very easy to remember. COV equal to SD upon mean multiplied by 100. Okay. So it is the percentage ratio of standard deviation to the mean. Variability. So range is affected by the outliers. Median is resistant to the outliers. Then SD measures dispersion around the mean, while coefficient of variation compares variability between the different variables. Okay. So coefficient of variation, how each observation is varying from each other, that will be measured by the coefficient of variation. While standard deviation will measure individual observation with respect to the mean, while coefficient of variation will measure individual observation with each other. Okay. So that is what is the coefficient of variation. Okay. So from examination point of view, for standard deviation, you need degree of freedom, which is n minus 1. Okay. So degree of freedom is calculated as a n minus. Sometimes they can ask you what is the degree of freedom. Okay. You have to see the number of observation and you have to subtract 1. That is the degree of freedom. Then box plot shows the outliers. Coefficient of variation gives the relative variability. Okay. Normal curve is symmetrical. Okay. So just final revision. Median is best for skewed data. SD measures dispersion. Coefficient of variation compares variability. You have got a positively skewed data, it will have a tail to the right. If you have got a higher CV, coefficient of variation, that means there is a greater variability. Standard deviation is an absolute measure of variability, while coefficient of variation is a relative measure of variability. Okay. So that is what is today's topic of measures of variability. Okay. So we have got few questions, Dr. Sansi, please go ahead with this.
Yes, sir. A researcher records maternal ages ranging from 18 years to 42 years. Which measure of variability is calculated using only the highest and lowest observation? Interquartile range, standard deviation, variance, range, coefficient of variation. Sir, option D, range.
Yeah, highest and lowest. Highest minus lowest will give you the range. Okay. So highest value minus lowest value, range uses only two extreme observation. So range is highly affected by the outliers. Okay. Next.
A data set is highly positively skewed with several extreme values. Which measure of variability is most appropriate? Range, standard deviation, interquartile range, variation, coefficient of variation. Uh, so coefficient of variation.
Your data set is skewed. No, there itself they have given the clue to you. When you have got a skewed data set, what do you calculate? Median. Once there is a
Median.
median, it will come the interquartile range, because you will go into the box whiskers. No,
Hmm.
you got
Oh,
it.
yes, sir.
Huh? Okay. So interquartile range, IQR means spread of middle 50% of observation. Okay. So median, and then comes the quartiles into the picture. Okay. That link should click in your brain. Okay. IQR
Yes.
is equal to Q3 minus Q1. It is less affected by extreme values and preferred for skewed distribution. Next.
Which statement regarding standard deviation is correct? It measures standard deviation is correct. It measures central tendency. It is unaffected by outliers. It measures the spread around the mean. It is calculated using only middle values. It is always equal to variance. So option C, it measures the spread around the mean.
Deviation is with respect to mean, while coefficient of variation is about the inter-individual observation. Okay.
Yes,
So
sir.
it measures the spread around the mean. Standard deviation. Standard deviation indicates how far observations are dispersed around the mean. Small is the SD, values are clustered around near the mean. Large is the SD, that means values are widely scattered. Next.
Two laboratory tests have different units and different means. Which measure is the most appropriate to compare the variability between them? Range, variance, standard deviation, coefficient of variation, interquartile range. Sir, option D, coefficient of variation.
Yeah, because we are talking about two samples with different units and different means. Okay. So coefficient of variation. So coefficient of variation is SD upon mean multiplied by 100. CV standardizes variability relative to the mean. Okay, higher is the CV, that means greater is the variability. Next.
A sample contains 20 observations. What is the degree of freedom used in calculation of simple variance? 19, sir. Option B.
Yeah,
N minus.
n minus 1. Okay, degree of freedom. You will be able to calculate now. Degree of freedom is the n minus 1. So 20 minus 1 is the 19. So sample variance uses n minus 1 and not n here. Okay, remember here
Yes.
you have to use n minus 1 when it comes to the degree of freedom. Okay,
Yes.
next.
Which statement regarding a box and whisker plot is correct? It displays only the mean. It cannot identify quartiles, outliers. The box represents interquartile range. Whisker always represents standard deviation. It is useful only for normally distributed data. Sir, option C, the box represents interquartile range.
Correct. Box represents interquartile range. Then there are whiskers. Okay. Then beyond the whiskers, you get the outliers. Okay. So the box represents interquartile range. The box and whisker plot displays median, quartiles, interquartile range, outliers, and spread of data. Okay. So length of the box is the interquartile range. Next, doctor.
Two data sets have identical means but different standard deviations. Two data sets have identical means but different standard deviation. What does the data set with larger standard deviation indicates? Lower variability, gathering, clustering around, greater clustering around mean, greater spread of observation, lower mean value, or smaller sample size. Sir, option C, greater spread of observations.
Because here it is related to the coefficient of variation will tell about the individual observation. Okay. Okay.
Uh, Option C.
Greater spread of observation. So larger SD means observations are more dispersed around the mean. Higher SD is the greater variability. Okay.
Hmm.
Next.
Which combination is most appropriate for skewed data? Mean and standard deviation, mean and variance, median and interquartile range, mean and range, mode and standard deviation. Sir, option C, median and interquartile range.
Because observations are skewed or the data set is skewed. So median and interquartile range for skewed distribution, median is preferred measure of central tendency, IQR is preferred measure of variability because both are less affected by the outliers. Okay. So that finishes the today's topic of measures of variability. Thank you.